So in this video I want to talk about how we use the TI-84 or TI-Inspire calculators to evaluate functions and evaluate their derivatives as we sort of go into Chapter 3 and start doing things with all that. So I'm just going to sort of jump right into that. I've got an example problem here. I want to say given f of x equals x squared sine x over e to the x, find f of 3, so evaluate the function at 3, and then find f prime of 5. So first f of 3. One option you have is over on your calculator, you can type in 3 squared sine of 3 over e to the third, and you can try just typing that in. But something I really want us to get into the habit of doing is anytime you're given a function and asked to do some things with it, use the y equals feature. Like, I feel like everybody, when they get a graphing calculator, they learn, oh, y equals, that's where you go to graph stuff. Kind of. Yes, we go there to graph stuff, but the real purpose, as far as I'm concerned, is doing stuff like this, working with this function. So I'm going to go into y equals and I'm going to type in this function. Even though it's not necessary, I'm going to put parentheses around the numerator just because it's a good practice to get into. So I have x squared sine x, all in parentheses, divided by, and again it's not necessary, but I'm going to put the e to the x in the denominator in parentheses because it's just a good idea to get into that habit. Oops. You actually want that closing parentheses to be on the line with the other thing. One thing I really like about the current operating system is you can see it uses smaller and larger parentheses to match up with other things. It's really nice. So now that you've got this in your y1, we're actually not going to hit graph. I'm going to go back to the home screen. Now I want to plug 3 into this function. So on the calculator, we can hit alpha F4 to bring up our y equals menu. Pick y1 because that's where we stored that function. And then use the same function notation. Over here I say f of 3. Over here I'm just going to say y1 of 3. And when I do that, it'll come back and tell me, hey, congratulations. We found out that f of 3 was 0.063. For AP purposes, by the way, they want to have at least 3 numbers after the decimal place, so that's the notation that I'm going to be using. Now the next thing, I want to know what f prime of 5 is, which means I need to take now the derivative of this thing and plug 5 into it. And I hope everybody's wincing a little bit at the idea of taking the derivative of this by hand. It's not impossible, but it's annoying. What I would much rather do is I would much rather use the calculator to do this. So to use the calculator to do derivatives, you hit the math button, and then you can either scroll down to number 8, which is annoying, or you can just hit the 8 button to get to here. And it'll bring up this nice little thing that says, hey, you want to take the derivative with respect to what variable, of what expression, and then plug in what. Right? So I'm taking the derivative with respect to x. Then in here, I could type my function, x squared sine x over e to the x, but remember, that's stored as y1. All we have to do is say, I want to take the derivative of y1, and then what number do I want to plug in? I want to plug in 5. We hit go, and it thinks about it and comes back and says, hey, congratulations, your derivative is 0.145. Fantastic. Based on what you learned from the first video, does this information tell me that the function is increasing or decreasing at 5? And you should be thinking about that for a second. But it should be easy. Because this derivative is positive, it means that my function is increasing at that value. There's one other component that I want to look into here, and that's this idea. How do we find critical numbers in the calculator? We should have learned in the previous video that critical numbers happen when the derivative is equal to 0 or is undefined. It's hard to tell when the derivative is undefined on the calculator, but it's easy to tell when the derivative is equal to 0. And again, that's what I'm going to be looking at next. So I have an example problem down here. Let's say I wanted to find the critical numbers of this function. Right, so I've got a function here. I want to find the critical numbers. That means I need to know where the derivative of this thing is 0 or undefined. So unfortunately, your calculator won't symbolically find a derivative. It'll only take a derivative and plug in a number. Finding a derivative you actually have to do by hand. So f prime of x, this is going to take the product rule, right? I'll have the derivative of the first thing, that's e to the x. I'll leave the next thing alone. Plus This time I'll leave the e to the x alone, and I'll take the derivative of the other part. That's 2x minus 5. And that is my derivative. Right? So now I need to know where this is 0 or undefined. And I'm going to make a statement right here. I know that this is never undefined. The only things that really cause a function to be undefined are division by 0. This problem doesn't even have division, so it can't be undefined. So what I really need to know is, when is this equal to 0? And the best way to do that is to plug this thing into the calculator and graph it. So I'm going to go to my y equals. I'll clear out what's in here. And I'm just going to type in what I have here. I have e to the x. Oops. Meant to hit this. Times x squared minus 5x plus 6. You can definitely fast forward this part of the video if you need to. It's not really necessary to watch me type all this stuff in. Times 2x minus 5. Okay, so I've got this whole derivative thing in here, right? If I now graph this, this is the graph of what that derivative looks like. And note, what I want is, when is this equal to 0? In other words, what are these zeros of the function, right? And the way I'm going to do that is by using the second trace menu. So second trace to get into the calculate menu, and then we'll choose number 2 for zeros. And you guys have seen this before, right? We can put in the left bound of 0. I can put in a right bound of 2, and say that my guess is, it seems like it's about 1. So we said that we were going to do second trace, and then we were going to go to 2, which is the 0 option. And then, as you can see, I found that one of those zeros was 382. And the other critical number, this one over here, same thing. We go second trace, 0. This one looks like it's between 2 and 3. I won't even put in a guess, I'll just hit enter again, and it'll come back and tell me my other critical number was 2.618. So these two things are my critical numbers. Right? So in the homework tonight, if you've got a calculator problem where you need to find critical numbers, that's how you do it. Hope that helped, and I'll see you in class tomorrow.